Hello class, today we're going to be working on polynomial functions and specifically graphing them. So we're going to start off with a question here, and our question is, we want you to sketch the function f of x equals negative x cubed plus 4x squared minus 4x. So take some time and see how you would try to even first attempt this. Now, you might say, heck, why can't I just, do this with my calculator and just copy the image? Well, we're going to assume the following. Assuming your calculator is broken, like that. That's one way. So we'll assume that. Now, with your calculator not being available, we're going to now try to figure out what we're going to do from here. Because if we try to sketch this function out, it might be a bit difficult. And the things you want to start off with is first figuring out where are your zeros, where it crosses the x-axis. So I like to start off by solving for that. So take a moment, let's see if you can find those zeros, and then you'll follow along with what I do. Alright, so let's break this down. The first thing I'm going to do is look at f of x is equal to negative x cubed plus 4x squared minus 4x. Well, we're looking where across the x-axis, making sure this whole thing equals 0. So where does that happen? The first thing I'm going to do is actually factor out, looks like x is a common term, and what I like about factoring out a negative x rather than just an x is that I want to get rid of this negative here. So I'm going to get rid of that by simply factoring out a negative x, and that's going to be left with x squared plus 4x, the square root for this one here is gone, and minus 4, and that's going to be equal to 0. So we actually have one part of our terms done here. Let's factor this out further, and if you do the FOIL factor method, you're going to get actually, this is x minus 2 and x minus 2. So you have three different sets of parentheses here. And we can set them all saying each one equals 0, and that's going to give us what our zeros are. Well, x is equal to 0 and 2. Now let's make a comment about this 2 here. This 2 has a multiplicity. Oh, that handwriting is awful. Of 2, meaning that there are 2 times it is going to be as 0 for x equals 2. So what does multiplicity of 2 mean? Well, it means that when we have multiple values for a single 0, right? So that means here 2, let me use point, 2 occurs twice because of these two values. It just happens to be 2 and 2, okay? It could have been 2 3s. If this was x minus 3 and x minus 3, it would have been multiplicity, this would have been 0, 3, and this would have been multiplicity still of 2, okay? So this multiplicity is of 1. If you have an odd multiplicity, we call that, this is referring to a slice. And if you have an even, which is the 2 here, you have a bounce. Now, what does that mean to you guys? I usually like to refer back to my base graphs or my base functions, and my two bases that I like to refer to are, let's do this, I'll do it in yellow down here. A slice is going to be simply talking about, you can actually consider y equals x, that's not great here, but the idea is that we go through the x-axis at a very sharp angle, a sharp point, like wah, yeah, like a slice, okay? And a bounce I like to use, so let me use y equals x. A bounce, this one here, is just, I like using y equals x squared, because x squared, right, y equals x squared, is going to have a multiplicity of 2. You have 2 times, it could be 0, right? And here, it is bouncing. It touches the graphical, boing, boing. whereas here it goes, yeah, right through. You can also see that for here, let me draw another one. For x cubed, it still slices, let me write y equals x cubed. It still slices through and doesn't bounce. It goes, this change in slope really, like it goes high, low, 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 0, and then it starts increasing, right? But it's still a slice into the graph across the x-axis, okay? So that's really important when we're drawing our zeros for 0 and 2. All right, so let's move on to our sketch. There's a few key things to also note. So let's highlight that in red. The first few key things is we already got our zeros. So 1, checklist, get zeros, where it crosses the x-axis. 2, find the final multiplicity, I guess. Put that in, find multiplicity. 3, find highest degree, or identify it, I should say. Find highest degree for your function. And note end behavior. I'll explain how this all fits in together in just a moment. When we look at here, let me use the pointer tool. First off, I'm looking for the highest degree, and that's going to be a cubic function for all this, and it's negative. So what does that mean if I draw my set of axes here? Okay, try to draw as straight as possible. So if I'm trying to draw my set of axes here, and I'm just going to say this is f of x, okay? If I'm going to draw this in, I automatically say to myself, well, I'm going to have a cubic, right? A cubic technically is drawn like so, right? We have that shown below. But we have to figure out exactly where it's going to hit the x-axis. So let's get rid of our cubic here and let's draw it in. So we're going to start off, I would say automatically, since I know it's negative, it's not a positive cubic, that I'm actually going to start off here and end down here. So that's like, now I'm just filling in the blanks basically. So the big idea is that we do have a 0 at x equals 0, and we also have it at 2, where x equals 2. And this is the part that's important, is to say that here we're going to have a bounce at 2. So how's that going to look? Well, if we look through here and try to connect the dots, we have to have a slice through here. It's not a great drawing here. But then we come back up, hit 2, and then come down. And that's bouncing off of the axis. Now, I drew that in here. I'm going to try to make it a little prettier. I'm going to do it, maybe if I do it from the right-hand side, I might get a better drawing here. So I know I'm slicing through. And I have to come back up and bounce off of the x-axis to get the 2. So I have this sort of curve going on here. And you might say, well, how is that actually true? Well, I've satisfied everything here. I've satisfied a slice and a bounce here for these two zeros that I've identified using this method. And the end behavior is also correct as well. So let's compare that. So just to verify, I went to GeoGebra and typed in my function here, okay, and just checking where our graph should it look like this. Well, we have our slice through 0 and our bounce at 2, just like I was saying before, and our end behavior, I'll mark it up, is oh, that's a terrible color for this on a white background. Let's do red. This is going to go up towards positive infinity as you're going to negative x values, and negative infinity for the output as you approach positive x values. So yeah, this basically is what we wanted, or what we sketched out. This one's obviously prettier, but in this case I have a general idea. If I had to like pick out of models, this is the trend that I would see if by my sketch. Okay, let's try to do another one. So for this one, we have sketched the function of g of x, which is equal to x to the 4th minus 2x cubed plus x squared. Give it a go, and I'll walk through it with you in just a moment. Alrighty, let's get started. So if I'm looking at g of x, and I'm setting this equal to 0, I'm going to be looking for anything that factors out because it'll be much easier to do with factored terms than what it is. So I have x to the fourth. Well, I usually like to factor out an x, but actually I'm noticing I have multiple exponents here and no constant value or constant integer value. So actually I'm going to pull out an x, and I'm going to pull out actually x squared. You'll see what happens in a second. This is going to become x squared, and this is going to become 2 to the x, and this is going to just become 1. I can actually really get used to using this because we can now factor this again. Say this is going to simply be x minus 1 twice. You can actually also say that this is x squared and this is x minus 1 squared. But if we're trying to solve for zeros, then our zeros are simply going to be x equals 0 and 1 multiplicity 2. So we could go to strictly to our sketch automatically, but actually there's another thing I haven't really got a chance to talk about, is this idea of you actually verifying your sketch with a number line method. So a number line method will say that we have our zeros placed, we say it's 0 and 1, and we take test values between here and see what's going on in this region, in between, and this region. And this tells us what our y values should be in the negative y values or positive y values. So let's plug those in. All right, I'm going to test. I want to use my marker here. I'm going to be let's use g of x. Let's do g of negative 1. Let's try g of 1/2 and g of, let's say 2. I think that's a safe one. If we plug those in quickly, we'll get negative 1 to the 4th minus 2 negative 1 cubed plus negative 1 squared. And this one's going to be 1/2 to the 4th. Oop. Said to the 4th, didn't write to the 4th. Minus 2 1/2 to the 3rd plus 1/2 squared. And this is going to be 2 to the 4th minus 2 cubed plus 1/2 in, no, this is going to be just simply 2 squared. And if we check these out, you're going to get negative 1 to the 4th, that's going to become 1, positive 1, minus, well, that's going to be minus 2 times negative 1, so it's going to be plus 2, and that's going to be negative 1 squared, that's going to be plus 1. We're going to get 4, all positives, so this is going to be positive. Now we're going to test this one. And it's 1/2, this is going to be 1 to the 16th, sorry, 1 over 16th. This is going to become 2 multiplied 1 over 8. 1 over 8 multiplied by 2 is going to become 1/4. And this is just going to be plus 1/4. Because 1/2 squared is 1/4. And we end up getting, if these cancel out, you're going to be left with a positive answer. Or I should have wrote that positive. So positive here too. Alright, let's just verify the last one. And in this case, you're going to have 2 to the 4th. 2 to the 4th is going to be 16 minus 2 times 2 to the 3rd, which is 8. This is going to be 16 as well, plus 4. Well, those 16s will cancel out, but you're still left with a positive. So yeah, what we notice here is that actually all our y values should be positive in our sketch. So let's see how we draw that. So if I were to put my axes here, the first thing I want to note is where are my zeros. So I have 1 at 0 and 1 at 1. Well, we also want to note, actually I want to use a different color, it's hard to see. Let's use these. Okay, 1 and 0. So that's 1, that's 0. We have a degree value, and the highest degree value here is going to be 4, an even number. Even number meaning that we're going to have a same action on both sides of the y-axis, like end behavior. So in this case, it's not a negative coefficient. So yeah, we got a touchdown going on here where it's coming down this way. So now we also want to mention that this 0 here should be a slice. Yes? No? Maybe so? No! Actually, there should be multiplicity 2 for both of them. Hang on. didn't put that here. I only mentioned it for one of them. Because notice that here, x squared is squared. This is also squared. So you have multiplicity 2 for both. So actually, they should both be bounces. So, in this case, if I bring this down, this should bounce off of here, come up, and get ready to bounce off of here. And it does. And yeah, that's my graph, g of x. Okay, and let's just compare that to GeoGebra. Alright, I brought that in, and I'm going to zoom in on it. Yeah, we have that too. Compare both together. Yeah, I mean, obviously theirs is going to look better. But, generally speaking, sketch is okay. Works alright, zeros are alright, end behavior is okay. Check marks for all. Good work. So I was glad you can join me for this lesson. Hopefully it was beneficial to you in some way, and look forward to seeing you next time. Have a good night.